Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Wauw. Jan Stomphorst, wat doe jij nou?
Nou, ik probeer je even te helpen.
Ja, nee, ik hoor het.
Een beetje energie.
Dankjewel. Nee, heel goed. Ik zou zeggen, doe dat vaker. Volhouden. Ja. Nou, ons laatste interview van vandaag over KubeCon. Op deze dag van KubeCon. We hebben er morgen nog veel meer.
Ja.
En heb je het nog steeds naar je zin, Jan? Vind je het helemaal leuk
ik heb net even swag opgehaald.
Ja.
Dus en dit jaar moet ik wel zeggen, er is wat minder swag.
Ja, heb ik ook dat gevoel inderdaad. Ja. En ik heb beloofd dat ik thuis zou komen met swag. Dus voor de kinderen. Dus we moeten morgen nog even ons best doen, denk ik.
We gaan morgen ons best doen. Maar
goed, daar heeft onze gast verder niks mee te maken.
Nee, daar heeft onze gast helemaal niks mee te maken. En vooralsnog gaan wij gewoon even naar onze gast.
Yeah, so I will switch to English. Now I would like to introduce Mustafa Hadadian. And I hope I didn't butcher it this time because I practiced it and it went very well. But Mustafa, welcome.
Thank you.
Mustafa, for the people who don't know you yet, can you please give an introduction of yourself?
Yeah, so my name is Mustafa, and my last name is Hadadian.
Hadadian, yeah.
Yes,
that's right. I heard myself saying it. I think, oh no, I know. Okay.
Oh, that's cool. Yeah, so I'm finishing my PhD at the University of Groningen, and it's been a year and a half. I started my startup company, which is also based on the product of my PhD.
Okay.
Yeah, I've been living in the Netherlands for almost 5 years now.
Nice.
Yeah.
And what got you interested in the IT? So how did you get started?
In IT, you can go back to my childhood, perhaps.
Okay, that's what we want to hear. What was the little Mustafa thinking when he saw a computer?
Yeah, so I was, I guess, 5 or 6 when we bought our first computer.
Yeah.
And I was used to play all video games, and
of
not
course.
a Windows game only. Also, the other games emulated on top of Windows. So that's how it started with the IT, and then also through my high school, I was developing video games.
Oh, cool.
Yeah, so this is how I get to IT. My studies also were on computer science. So I've been in, so I tried to continue with game development, but then I moved to data processing, and then big data processing, and then my PhD, I switched to, let's say, not only data processing per se with this Apache big data, but I tried to build something, so not to be a consumer, also be a producer, so like build a platform for data processing.
Okay. And I have to ask, what's your favorite game?
There are a lot of one.
Yeah. You can name a few. I'm interested.
FIFA.
FIFA, of course.
Yeah.
Okay.
Yeah, I've been on the top 200 on the global leaderboard.
Oh, nice.
Yeah. Something to brag.
yeah. With your
awesome.
foot for your ultimate team.
Yeah.
Okay, nice.
And then I got. I thought that okay, this is an obsession. I have to leave it behind. Otherwise, I will be spending all my time playing game. But the other video games that I like, for example, God of War, Devil May Cry.
Nice.
Age of Empires from old age.
yeah. Age of Empires to LAN parties and stuff, right?
Yeah.
Man of culture, I hear. Yeah. Nice.
Real culture.
Yeah. You have a talk here, and it's a very long name. The Extensible Kubernetes CRDs via inheritance for modularity and reuse.
Yeah.
Can you tell us about what it's about, the talk?
So this is this was a poster session.
Yeah.
We were doing this with my master student, Nick, which we worked on this project as a side project of a bigger project called ESIDA, which is for evolutionary changes in data analysis. And we tried to implement is-a relationship in Kubernetes, because we used to use this technology in Java, for example, in object-oriented programming. And then we sense, okay, this is something that Kubernetes is missing. So let's try it out. And what the motivation is that so that you can have, let's say, a general interface and let's say switch the different implementation. For example, you can have a service definition, which is the API, and a service implementation, which actually implements that API. So give you a bit more, a specific example is that, for example, you have a message queue.
Yeah.
And this is what the app developer cares about. They want a message queue. But for example, the platform engineers is the one who is saying, okay, for this message queue, I want to implement this via RabbitMQ, or I want a Kafka. So based on the requirements of platform engineer, they will decide, okay, this should be, which controller should take this resource.
Right.
And this is one of the use case. Yeah. The other thing is that so you will have a general API, and you will have also a specialized API, like the old school example. You have animal, cat, dog, and if you want to get all the animals, you can call it from the API of animal. So if, for example, you want to have all your message queues, either it's a RabbitMQ or Kafka, you can say, okay, kubectl get message queue. You will get all. And if you want to configure all of them also together, so you can communicate through the general API, or you can specifically configure the specific ones.
Okay. Just for me and maybe some other listeners, this CRDs, the custom resource definitions, aren't they extendable from the get-go, or is there something else you need to go? I'd also look to you. Is that?
No, they're not extendable per se. They're extension of Kubernetes base resources. There's a Kubernetes API.
Yeah.
But if you want to extend a CRD, there is no mechanism out there.
Okay.
So a CRD is a custom resource definition, and you create that for a custom resource.
I know. I'm familiar with that, but I'm not the extendable part.
Yeah, what are you extending then?
So, for example, you already have one CRD with operator with a controller which is already working, and you want to extend on top of that. So you still want to have the general one, but you want to extend the schema of, let's say, a child one. And you want to, for example, after that, build a chain of inheritance, like we used to have in Java, for example.
Okay.
So it will enable you to reuse other components without, let's say, copy-pasting everything and having duplications, maintenance.
You said the magic word. So
yeah?
Yeah, you said Java.
Oh, no.
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 Okay, this is a running gag in the podcast. But
heap. But
yeah.
Sorry. But now it's... so you're doing an CRD like on message queues, just keeping in your example, and then extend your CRDs with RabbitMQ and Kafka. So the extension is possibly a different kind of software.
It's a different CRD.
Yeah.
But in this example, actually, it's like abstract classes and concrete classes in Java term, which you can have, let's say, abstract message queue and implemented by, for example, Kafka, or implemented by RabbitMQ. But
and if you have to explain that to him or to our listeners,
who are not like the tech guys, but.
How do you, in simplified terms, how do you explain that?
Let's say there are two aspects to this. One is abstracting, and how I can explain is that the developer doesn't want to care about how this thing should be deployed in Kubernetes, but this is something that the other person, let's say more techie guys with the Kubernetes experience, they care about the implementation. So you will have an abstract interface API. I guess this is somehow general. So you can also understand it.
Yeah. I'm not that. I can understand.
You're not that stupid. No.
I wouldn't say stupid, but it's
no,
fine.
You're not stupid.
So you can have this abstract API, and then you can have a specific implementation for that, which in Kubernetes or in operator terms, specific controllers,
Right.
who can pick this up based on their requirements. So this is for one part. The other part is that when you inherit something, so for example, I will go with deployment, because it's a well-known resource, and you want to extend the behavior or extend what Kubernetes already offer, and you want to put, for example, more thing to this custom resource, but you don't want to replicate the whole CRD of or a definition of deployment.
Yeah. Okay.
So you want to add only a few things to that. So you should be able to do that and not copy pasting the whole deployment. So this is
sure.
inheriting.
I'm familiar with the term inheritance and how that works. I worked with Windows and user groups and inheritance and rights and stuff, and it's always fun.
Yeah,
and you have the option. What was the option always? Don't look at the inheritance. Well, otherwise you cannot delete or change anything that is inherited from the top down.
Yeah,
So there are other sets of rules. I don't know if that also applies from this on this part, because if you inherited of extended CRDs and you inherited from the from top down, and you say from I'm at this level, a few levels, like say 3 levels down, but I don't want that inherited part in this situation. Is that something also you say from that's you cannot like remove that part and the top 2 levels above still have that inheritance, right? That's another way of looking. You understand where I'm coming from? I'm looking at specifically from a rights perspective, and maybe it doesn't really
I think
apply.
it's a bit different. It's not. I think it's not applicable.
No, I'm trying to get my head around it. I know the inheritance part, but
So, to keep it simple, so we've got deployment, and we're extending that and keeping deployment as a whole, and extending that with some extra values and stuff. If we do Kubernetes upgrade, and the deployments API changes, what happens?
So you're pointing at the when you're extending, you're pointing at a specific version, so it doesn't directly affect.
Okay, yeah.
Unless you want to update also your extension.
Okay, so I have to do manually check and do a new version of my development API, and then extend that again to support my application.
Yeah, so technically you should be able also to do, let's say, automatically updating. But when we first proposed this, we come up with this problem that then your platform is not predictable, because you don't know which version actually is running right now, and what was the behavior that was expected from this. So then we said, okay, let's for now fix the version referencing.
And why don't I want to copy the complete object? So why don't I want to copy the complete deployment and put that in my CRD?
Because then you will be replicating your CRDs. And imagine just you have a chain of inheritance. And then you will also lose the controller mechanism delegation, because when you're extending that, you are also you'll be able to use the parent controller for taking care of the inherited part, and your controller only take care of the extra parts, and also taking a look at the whole system to synchronize.
Okay, so I can use the deployment controller if I extend the deployment.
Yeah, right. That's correct.
Do you understand that?
Yeah.
Whoa.
This is more your part, you know.
And yes, sending. You're saying I'm extending, for example, the deployment multiple times, and so layer deeper, and then layer deeper. But what is the use? You said the use case, But do you have more use cases for that?
Yeah, so the main use case for us, or the idea, the way why we started with this, was with data processing pipelines.
Mm-hmm.
So, for example, you can define the behavior for how to manage a classifier as a model. Then there will be some specific classifiers that needs a specific attention for how to deploy those. Like, for example, some of them may need, they are GPU intensive or they are CPU intensive. You will need, okay, which kind of resources should I give to this? And then you may go one level, for example, deeper for some specific, so for example, let me think. I cannot come up directly with a example right now, but let's say you have one classifier, then another classifier based on that, so you can go deeper and then specializing different types of.
If we go to your message queue example.
Yeah.
So I'm a developer. I want a message queue, and I've got a platform team that creates Kafka and RabbitMQ profiles, or CRDs. What do I do then? What do I have to do as developer?
What kind of developer? You were speaking like the developer. No, I mean, but
The developer of the
app.
software. You have the app.
Okay. So as the developer of the app, so you only need to define that, for example, you need a message queue.
Yeah.
And you will fill your resource, your YAML file, and that's what you need to do. But we will have, let's say, platform engineers. They are taking care of the Kubernetes part or the deployment, how this CRD should be translated to built-in resources, let's say. For those, this makes difference that how to translate this general message queue one to either, let's say, RabbitMQ or Kafka. And the ways that, so the application developer fill in the spec, and the platform engineers has the option to annotate this resources. Either it should be implemented by Kafka or RabbitMQ, and then also the platform engineer needs to develop two controllers, one for RabbitMQ, one for Kafka. And based on the annotation, it will say, okay, if annotation is RabbitMQ, the RabbitMQ one will work on that and drop the Kafka ones, for example.
Okay, and if we want to extend that CRD then with something else like a secure connection or something else, is that then done by the developer or by the platform team?
Platform team. So, for example, can go one level, let's say, deeper for Kafka. That's what we experienced.
Mm-hmm.
Is that you may need some messages or short messages.
Yeah.
Needs different configuration, but sometimes you may have, let's say, bigger messages. And the priority, for example, for someone is throughput, for the other one might be latency. So different configurations going on, but so still it's a Kafka type message queue.
Yeah.
But based on the need, still needs a specialized tuning.
So
which can be extended.
Can we see it then that we're abstracting a bit away from the developer? So the developer only says in his YAML deployment, I want Kafka and I want secure or short connections and I want something else. I put that part in my YAML, and Kubernetes translates that to a complete Kafka installation with all the things I need, and that's made by the platform team.
Exactly.
You got it?
Do you understand it also?
Yeah, I think I need to re-listen this episode when it's coming out, and I will get it figured
No,
out.
but it's
I think it's not that difficult to follow, but it's
like
abstracting. The first time you're hearing it, and if you're not coming from like a practical use, I'm not a practical Kubernetes user. You know, he's working it with it every day, and I know what he's talking about, but don't ask me to repeat it, you know? And that's
Yeah.
But it's just repeat, and it's just extending your CRD. I'm gone. It's very easy.
yeah.
So that's cool. So that's a practical use. And you formed your company around that, you said.
It's not around this. This is a side project,
Mhm.
which we are now. It's an incubation.
Right, okay.
But the company is based on say on the other project. The ACIDA project is the main one, and that for that it's running on a different design pattern for controllers, which implemented has a relationship, which is, let's say, more of a composition. And then we saw, okay, it could be cool if we also have is a relationship, an inheritance. And then with Nick, which was a master student, we initiated this project, and he's been working on this project so hard, which we made it to make a good proof of concept that we were able to present in just today. And we got a lot of attention actually for that. And we saw that there, or assumption that there is a need for it, it's validated to some good extent, because we saw a lot of people interested in this approach.
Could you tell us the proof of concept?
So the proof of concept of this side project is, so we implemented that with mostly with operators. So, for example, for inheritance part, you can have a controller who is syncing between parent and child. So we do have an inheritance controller, which always keep track of this inheritance chain. And for the user, it should be very easy to use it, because it's just configuring your inheritance with annotations. So you don't need to change so many things. You just need to add some annotations. Then our controller will pick that up and will understand, okay, this is an extension to the other one. I need to know that. I need to create this resource as a concrete one, so that the other Kubernetes operators understand that. And it will allow you to interact with both parents and child through both APIs. Like, for example, you can configure all your message queues through kubectl, patching them, or you want to get all your message queues. Keep using this message queue example, but it's more generalized, so you can be anything. But you can say, for example, kubectl get all message queues. So it doesn't matter if it's implemented by Kafka or it's implemented by RabbitMQ or other message queues, you will get everything. Or you can configure all of them, and you can also have control over the specific or specialized resources, also through their specific APIs.
Okay. Awesome.
Yeah. I was thinking, should you also do it explaining in Dutch? Just
We'll use AI for that. Are you using AI also for that?
No, in this specific part, but in our main project, we use AI, and the ACIDA project, because it's a project for data processing, and we do have a lot of, let's say, AI modules or any kind of data processing modules, and each of these modules has some definitions. What are the inputs? What are the outputs? Perhaps some description of what they do. And we do have a service that you can, for example, type in that I want a data processing pipeline that gets this data and do this and output that. And based on the available things that you have in your repository, it will try to create a pipeline automatically for you, so that it is doing your job.
Okay.
Okay. Your project, is that open source? Because it's
everything is open source in our project.
And where can we find it?
It's on GitLab. It's a Dutch part, so like we use GitLab. GitLab.com/ACIDA. Yeah, that should be it.
ACIDA. And how do you spell that?
ECIDA. ECDA.
Okay.
Evolutionary Changes in Data Analysis.
Look, that's a nice name. You found it?
Yeah. Cool.
Cool.
Thank you.
Yeah. I think we're up for our final question. And,
You can ask.
yeah,
huh?
I will ask that question. You asked a lot of questions, but it's good. Mustafa, if I would put a crystal ball on the table, how would you like to see the future of Kubernetes?
Okay, my mind goes to the crystal ball. The
right,
future.
Yeah. We're still working on the crystal ball physically part, but that's maybe in the later.
From the experience and the talks that I see, so Kubernetes is also adapting very quickly. So that's a good thing to see. The community is developing a lot. I think that currently Kubernetes is the current, and I guess it will also continue to be the current. So like it means that it's also the future.
Yeah. I know.
Because I see that there are a lot of things happening around the AI things also with the LLMs, which I guess when I started my company, when we were discussing about LLMs on Kubernetes, it was like, no, that's not the way you go, because you need supercomputers, not this distributed computing. But now we can see that the community drive that also for adapting these types of workloads.
Yeah, they're almost expecting it to put it on Kubernetes.
Yeah.
Okay. Well, nice.
Cool.
Yeah. Well, Mustafa, thank you for this explanation, and I learned a lot. I think what I said, I need to get my head around it because it was quite technical on this side. But again, thanks again for explaining it, and hopefully the next time we talk to you, we can have a deeper discussion. And I'm curious where your company and the development of this project leads to. Thank you very much.
Thank you very much.
Yeah, thank you for the invitation and also leading this podcast. It's very interesting to see it.
Yeah. Okay. Well, thanks.